Okay, the last lesson of this first half of Chapter 4 on transformations is still about rotations, but then we're going to start doing some combinations of rigid transformations, and that's going to get kind of interesting. First off, rules for rotation. Basically, and I will give you notes on this for the quiz. You will not have to memorize these rules because they get really confusing. But when we rotate in the coordinate plane around the origin, we can use the following rules. A rotation from A to B that is 90 degrees takes the point from AB to negative BA. So it switches the order and the sign of B. A rotation of AB goes to 180 goes to negative A, negative B. 270 takes AB to B, negative A. And we'll see very quickly how this works in the coordinate plane. And again, memorization of this is really not required. I'll give you these. So if I have RSTU with the following vertices, without graphing, find its image after 270-degree rotation around the origin. You may notice these are the same coordinates we had yesterday. Actually, we'll use a correct U coordinate this time, unlike yesterday. But we'll go ahead and do the rotation and see what we come up with. So the 270-degree rotation rule is AB goes to B, negative A. So we'll make note of that. So R primed, we're going to switch the order, 1, 3, and the A is going to change signs. So R primed went from 3, 1 to 1, negative 3. S primed was at 5, 1. We're going to switch the order to 1, 5, and we're going to change the sign on the second one, so negative 5. T primed went from 5, negative 3 to negative 3, 5, but we have to change the sign on the second one, so negative 3, negative 5. And U primed went from 2, negative 1 to negative 1, 2, change the sign on the second one, negative 1, negative 2. So without doing any drawing, without doing any complicated work, we're working in the coordinate plane like this. Just using our rule, we can very quickly come up with the coordinates for the rotation, and then plot those coordinates if necessary. So using our rules is fairly simple. We just learn what to flip and what to use for signs. And again, I'm not going to ask you to memorize because it's too easy to get them confused. You just need to be able to use them. That's what's important. What's more interesting is when we start doing combinations of reflections. So we call these compositions. In this case, I have a segment with endpoints R and S, and I want to find its image after the composition of first a reflection, then a rotation. First a reflection on the y-axis, and then a rotation. So what we're going to do is we're just going to do them one at a time. We're just going to do the reflection first. We're going to completely ignore the rotation, and we're going to find R primed S primed. So reflecting in the y-axis, if you recall, just a quick sketch to help us remember what's going on. Reflecting something in the y-axis, the point is 1, negative 3 for R. If I reflect that in the y-axis, I'm just going to change the x-coordinate, negative 1, negative 3. Aha, so R primed is at negative 1, negative 3. And likewise, S primed going from 2, negative 6, which would be way down here, somewhere is going to flip over here to negative 2, negative 6. There, that reflection was quite simple. Now that we have the reflection, we're going to use that as our pre-image, and now we're going to do our rotation. So now, 90-degree clockwise around the origin, I go back and check. AB goes to negative BA, so I'm going to make note of that. For 90 degrees around the origin. So, R double primed, we're going to switch the order negative 3, negative 1 to, or negative 1, negative 3 to negative 3, negative 1, but we're going to change the sign of the first one, so 3, negative 1. And S double primed is going to go from negative 6, negative 2 to 6, negative 2. Because we're going to switch the order and change the sign of the second number, B, negative 6 to a positive 6. So those are the coordinates after the composition of reflection and rotation. It's just using two different rules to do two different motions. We do them separately. We don't try to do them all at once. We do them one at a time in the order that they're given. Translation and a 90-degree rotation. Again, 90-degree rotation, AB goes to negative BA. I only remember that because we just did it on the previous page. Translation is down 2 and left 1. So x minus 2, y minus 1. So A primed is down 2. Negative 4 minus 2 is negative 6. Y primed is negative 4 minus 1, which is 3. And B primed, with just the translation here, is x coordinate down 2, so that's negative 3. Y coordinate down 1, that's 6. Then we do the rotation. 90 degrees around the origin. AB goes to BA, so A double primed goes from negative 6, 3 to negative 3, negative 6. Because we switched these two, we've switched them around and changed the sign of the first one. And B double primed goes from negative 3, 6 to negative 6, negative 3. And those are the coordinates for the endpoints of A double prime, B double primed after both translations. Again, just do one translation at a time, or one transformation at a time in the order they're given. You'll have no problem. You're just putting steps together. Again, we could graph this after doing the rotation and the reflection. Let's go ahead and do that. Rotation 180, we haven't done one of those yet, so let's look at our rule for rotation 180. AB goes to negative A, negative B. Okay, so that means AB to negative A, negative B. So we're not going to do it in the coordinate plane first. We're just going to do it according to coordinates. So let's find T primed. T primed was from 1, 2 to negative 1, negative 2. U primed goes from 3, 5 to negative 3, negative 5. And V primed goes from 6, 3 to negative 6, negative 3. We keep the order, we just change both signs. That's my rotation. Now we're going to do the reflection in the x-axis. Reflection in the x-axis, you recall AB, x-axis changes to the y-coordinate, A negative B. Or if you prefer, you could plot a point and check it in the coordinate plane. So T double primed is going to be at negative 1, positive 2. U double primed is going to be at negative 3, positive 5. And V double primed is going to be at negative 6, positive 3. The actual graphing of those points is trivial. That's something that you can certainly do in your homework. I don't think I need to demonstrate that for you and spend a lot of time. So when we have compositions of transformations, we simply do them one rule at a time and work through it. And remember, the rules are going to be given for you on the test, or I will write them on the board. Please remind me if I don't have them written on the board for you, so that they are written on the board so that you have those rules available to you for the quiz. All right? That's it for this first half of Chapter 4. See you in class.